we're looking at here at a root function, which we're going to be graphing with a host of transformations in it. Let's begin by listing them. So we notice over here we have the negative, which means that it's going to be reflection in the x-axis. And the 3 outside here means we're going to have a vertical stretch by a factor of 3. Now the negative in here, okay, this is something we haven't really seen before, means we're going to have a reflection in the y-axis. Okay, and the 1 over 2, let me just maybe highlight that, the 1 over 2 over here means we are going to have a horizontal stretch by factor of 2. Now I say 2 because it's the reciprocal of this value here. Okay, that's one of the things when we look at the b value, we're looking at the reciprocal of it to state the stretch factor or compression factor for that matter. Next we have the negative 10, which is going to shift us horizontally to the right 10 units, and the plus 2, which by the way is outside the root sign, okay, means we're going to be shifting up 2 units. I'm not going to bother writing those in because I think they're pretty straightforward. So let's begin by, in this case, let's use the mapping notation to get the points. Okay, so if you recall, a root function for x and y, the base values are 0, 1, 4, and let's say 9. So 0 goes to 0, 1 goes to 1, 4 goes to 2, 9 goes to 3. Again, remember, it's f of x equals root x. So I'm using perfect squares as my x value because they're easy to calculate. Now for the mapping of this transform function, I'm going to set up my kind of general template for this stuff. And I know that I'm going to write 1 over b, x minus the h value. And then I'm going to have ay plus the k value. Now in this case, my b value is negative 1 over 2. So I'm going to just use the stuff from, here, 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 and here. So I'm going to have x comma y maps to, so 1 over negative 1 over 2. Okay, if you do the math on that, you just end up with negative 2x, and minus h minus 10 will be plus 10. Oh, sorry, minus h replaced with minus 10 will be a plus 10. Then I have a negative 3y, and then I have a plus 2 value over here. Okay, so let's start by plugging in these points and seeing what we get. So I got 0, 0, 1, 1, 4, 2, 9, 3. I'm putting them into my my map here, and I end up with 10 comma 2 is the first point. 1 comma 1 is going to go to 8 comma, what is that, negative 1. 4 comma 2 is going to go to the point, let's see, negative 8, and it'll go to 2 comma negative 6 plus 2, negative 4. And finally 9 comma 3 is going to map to the point negative 8 comma, what is that, 9 plus 2, that'll be negative 7. Okay, so the points that we're left with here on the right hand side, that's what's going to be our transformed equation. So let's just kind of roughly sketch these guys out. Okay, so I'm going to draw a set of axes here. So there is my y, there is my x, and I'm just going to do some rough numbering over here. So 10 to, let's say that's 5, that's 10, so that's 5, that's 10, that's negative 5, that's negative 10, and we'll go all the way up to, let's say, 5 and 10, negative 5, and extend this, and negative 10 down here. Okay, so 10, 2, roughly over here, my first point. 8, negative 1, let's see, 5, 8, roughly over here. Again, roughly, I don't have grid lines. 2, negative 4, roughly over here. And negative 8, negative 7, again, eyeballing it to be somewhere over there. So, now if you recall, the original graph goes something like this, right? Something like that. Obviously, it's not drawn properly because, you know, out here it should be a bit lower, but whatever. The new graph, remember, this point went over here. So this point is now your beginning, you know, in quotes. It's not, you know, it's the beginning of the function, and it goes from here outwards. Again, that's a crude drawing, but the idea is right. Okay, again, you want a good drawing, just use a computer. Now at this point, I mean, we're done. Oh, sorry, let me put that back in. We are done in terms of the graph. Obviously, if you have grid paper, you can do a much better job than I. But it's good to check that what you've done is actually, you know, especially with the reflections, that it, you know, it's a good representation of the function itself. Now, the first thing is, okay, in here, the negative 3, remember, that's going to reflect us in the x-axis. So let me use a different color here. This original one will be reflected down here. I don't care about the stretch, compression, any of that stuff. I just want to look at the reflection. And then this 1 over 2, can't really see it. Let me erase some stuff here. This 1 over 2 here, this negative 1 over 2, means we have a reflection in the y-axis. So again, with a different color, I'll use blue. This last one, which we reflected, is going to be reflected over here in the y-axis. Now you notice that our final graph is in the same direction, okay, the same general direction as, you know, the graph after the reflections. And this is what really matters. It's not so much, you know, how accurate your graph is. Again, a good graphing calculator or a computer can do that. It's that you understand, you know, just the general behavior of your function, okay, of your transformed function. And this is good, okay, it's going in the right direction. Again, the stretch factors, they're hard to see, especially for a graph like this. But again, a detailed sketch will reflect those stretches or compressions. One last thing we want to include, though, is the domain and range. Well, this is not too difficult. The domain, let's do that in black here. The domain is going to be all real numbers, okay, such that x is less than or equal to 10, okay, because it's everything from here back. And the range is going to be all real numbers such that y is less than or equal to the value of 2. Because again, it's up here at 2 that we have you know, our topmost value. So there is our function graphed.